Time to start. Can everyone hear me? Cool. So, my name is Jan Vidar Krey, but for simplicity, don't mangle it, so just call me JV. I'm the head of development at Promon. We do app shielding technologies, and this is what I'm going to talk about today. This is not going to be a sales pitch because I'm not here to sell a product, but I do have a couple of sales guys upstairs if you want to meet us afterwards. I'm just going to talk tech for the most part. And a little bit who we are. We are basically a startup company, scale-up company based in Oslo, Norway. And we do this new cybersecurity technology we call app security or app shielding. And right now we are integrated into lots of apps with roughly 1 billion, a little bit more than 1 billion end users. So what is app shielding? That's the big question. This is what Gartner has to say about it. But you're not here to actually hear what Gartner has to say about it. So I'll tell the story more the way I want to tell it. But before we do that, I'm just going to talk a little bit about what it actually means to develop apps. So this is a typical app, right? You have your phone, some internet connection, and some backend things, probably in the cloud. And there is some data connection stuff happening, calling the server, getting some data, presenting it to the user, and so on. That's kind of pretty much every app. I think if you are not developing an app like this, then you are either doing a clock app, or I'm not sure what you're doing. Maybe you're doing an offline game, could be. So the way I like to think about app security in this sense is that you already spent quite a lot of resources on your backend protecting your data on the server side. You have like a firewall, you have maybe even a web application firewall in front of it, protecting your databases and whatnot. And you have encrypted communication going back to the device where this app is running. And I assume that most people in this room are probably not working on the backend side of things, actually working on the apps on the phone. So this is basically what app shielding is. Additional security that you can build into the application itself to make it more resilient, make it self-protecting even. And this is not endpoint security. At the end of the day, if you have a big app out there, unless you're an enterprise and your users are basically your employees within the same enterprise, your users will be running this application on whatever hardware they have. So how do you protect this? And of course, this app shielding does not replace kind of the need for having a good development practice in the first place. That's a bit like putting lipstick on a pig. You can make it nice, but at the end of the day, it's still just a pig. And you still have to do the fundamentals correctly. So I like to think about app shielding as like two different aspects blended together. So one of them is like, how do you protect your application when the application is not running? And the other one is, how do you protect it when it is running? That sounds a bit weird, maybe. But it also depends a bit on what type of application you have and what type of data you're trying to protect at the end of the day. So some might see this as more like a static protection versus dynamic protection. But I'll talk a little bit about what these two different are. And I'm going to show you a little bit what you can do with the certain things on, for instance, at-rest protection. So starting with the at-rest attacks, like if you have an application out there, what can we actually do with it? Well, you can reverse engineer it. That sounds really like, so why would anyone reverse engineer my app? I'll give you a few examples on that. You can repackage the app, which is maybe a special case of reversing it. But also, you can extract data from the app. Also extract data from the app being used on users' devices. So when I say, why would anyone reverse an application? That sounds a bit fluffy, maybe. What do we actually mean? It could mean a lot of different things. If your app is a game, it could be all about how do I cheat in this game? How can I make an advantage for myself? And as a game developer or as a game studio, you basically want to make sure that it's a level playing field. However, I mean, there are lots of non-games out there as well that have kind of issues as well. What we are seeing is that some apps are being repackaged. You basically take the application, you disassemble it, or you pull it apart, and then you can change like the advertising IDs used inside the app. And now you can publish it on a different app store, which is not called Google Play, because you didn't put it there first. So now someone else is getting your revenue for the ad impressions. So that's a very concrete thing which we are seeing happening. So what can you do about it? So starting from the bottom, I mean, you can encrypt your data. That's a pretty good and sound advice. But it's also not straightforward exactly how do you do that. Sure, you can, I mean, everyone can encrypt something, but if you ask a cryptographer, now you have a new problem, and that is how do you deal with the encryption key? Again, maybe you can encrypt that too, with a different key. I'm sure you'll figure it out. And how do you prevent someone from actually repackaging and basically publishing an app with some modifications? I think you can check some yourself. Basically, make sure that you have the cryptographic hash of the exact app while it's running. And if it's not, then it's not your app anymore. So this is something that you can actually do. And I think lastly, code obfuscation. That sounds like a good idea. Does anyone actually use code obfuscation here? Wow. Nice. All right. I will actually do a very, very simple example of what code obfuscation can do and what it cannot do. So I took the liberty on a plane here to actually write some code. The code isn't all that interesting, but it's all about calculating the possible moves for a chess piece on chessboard. It's probably not complete, probably not the best code anyway, but this is what it is. You can compile this and you can run it. And you can put it inside your game. Now, if you want to obfuscate this, there are some tools you can use. I mean, if you already are using code minification on Android, you have like the R8 compiler, which is replacing ProGuard. Okay, so let's do that. That will give you code like this. And now you think, no one can understand this one. Because now we have changed all the names, so it doesn't say that there is a chess piece there anymore. There's just a lot of A's and B's and whatnot. The problem with this is that structurally it's still the same. This is the control flow. Which means that you can compare the control flow before and after obfuscation and basically observe that they are the same. And now we can try to analyze and figure out what's actually going on there. But there is a way to do this with code obfuscation, which is essentially fixing it like this. And if you add like a big switch statement on top, you have now, instead of having a kind of a vertical control flow, you now flatten it so that everything is like this. And if you do it once more, it will look entirely different. So that's pretty good. Obfuscation is a huge kind of field of research. This is actually pretty basic. But this is not something that you get from using R8 today. The problem with this, if you look at the code, maybe you don't look at the structure at all. At the end of the day, you have this one method, which is calculating some chess moves. And you see that it's a method called A. Okay, I have no idea what it does. But if you actually attach a debugger to the application, you will see that it takes a number of parameters and it returns a list of something which looks suspiciously like chess moves. Which means, as an attacker trying to reverse and figure out what is this method doing, I basically already decided that I don't have to take a look at this, because I can see what it does. I don't know, or I don't need to understand how it does it. And this takes us a little bit over to the runtime protection aspect of it. Which means that if you obfuscated your code, but you still allow anyone to attach a debugger, it just means that you're putting a small speed bump on top of anyone trying to understand what this application is doing. So if that's adding like a game cheat modification, you can find it using a debugger. You can inject code into the application, which means that we can have the application do other things than it was designed to do. And the way to do that is either through a debugger or to use something we call like a hooking framework, which is essentially a way of rewriting the executable code as it's running. Some of them are actually really, really nice to use and really easy to use. I'm not sure if anyone actually has used any of these, like Frida. No one? One? Cool. LS Post. Nope. You can actually jailbreak your device or root your device, and you can install a hooking framework on it. And then there is like an app store where you can basically download modifications that will apply to all these different applications. So you can download your favorite, unlock the speed hack on the game, or manipulate kind of money transfers if you have a payment app. That's pretty bad. And of course, emulators. I mean, that sounds like it isn't really a problem, right? It is a problem if you have thousands upon thousands upon thousands of emulated users that aren't real users, and that's destroying your monetization. All of these are pretty... You have to go quite deep in order to protect against these. So I'm not going to go into the details on how you can actually prevent anyone from injecting code into your application. That's definitely something which could be a problem for certain apps. What's a little bit more high level though, I mean, these type of attacks, like manipulating like the user interface, the experience of that, is a lot easier and actually very, very common. So I don't know how many in this room actually downloaded a new keyboard for their Android because, well, the colors were wrong, or for whatever reason, but there are hundreds of them in the App Store. And do you know what they are doing? Well, I don't. I've looked at a few that looked a bit suspicious. Some of them are like sending everything that you're typing into the application back to the server so that they can do like better predictive word completion. That's pretty cool, right? But it also means that everything that you're typing into that application, or into any other application for that matter, is being logged on some server somewhere. And if your application is dealing with sensitive data in some ways, that might be a problem. So a good way to actually deal with that, depending on what kind of data you need to enter into your application, could be like you have a PIN code entry. Just put the 9 or 10 buttons directly into your application and you have solved this problem, more or less. Instead of having the keyboard application on top, which is sending everything back, potentially. There's some UI overlay stuff. Click here, and it goes straight through to the application underneath, and all of a sudden you have accepted all the terms and conditions. Or done something that you shouldn't have done, I guess. That's a very real thing. And lastly, we have what I usually call a screen reader. But it's really called accessibility services on Android. You know what it is? Cool. So, screen readers basically allow you to control absolutely everything, any app on your device. It does not require anything from kind of a security point of view in terms of you don't need to break your device or anything like this. It just means that you need to get a user to opt in and basically allow this to happen. So here's a random screenshot I got of the internet, which is basically attached to an article which explains how you can enable a screen reader in order to get some password managers to help you, which is all good, right? So whenever you're entering a site or an app that requires a username and password, this one will basically read the contents semantically on screen and basically see that, here's the username field and here is the password field, and it will fill in the data and submit it for you. That sounds pretty good. The problem with it, of course, is that we are training users to enable all sorts of accessibility services. Admittedly, Google Android will show you, are you sure that you trust this application? But I think this is a little bit like we used to have this recommendation, I don't know, 20 years back. Don't open random attachments. Don't install random apps from the internet. So now everything is from Google Play. It's all good, right? The problem is that this is very, very common and commonly abused. So how do you protect against it? It's really simple, actually. You can prevent your app from sending data to these screen readers unless you actually know which screen readers are there. So we actually do a quarterly app threat report. And in Q2 this year, we actually did what we call the state of financial services and the malware defense. And we tested the top 100 applications which were listed in Google Play as these are the ones, or in the financial apps category. And basically we tested, is it possible to do this and exfiltrate all this data and basically control these apps? You can guess. Is it possible? So the answer is yes. I'm not going to name names. But the vast majority, and then some, did not have any kind of a protection against this, which isn't all too surprising.
Do you have the names of the 8%? Who are really good at it?
I do, yeah. But I'm not going to name names. So I think to conclude, how do you actually protect your app? How do you make your app better and resilient against many of these app security threats? And how do you actually do it in practice? I think it's very, very simple. You start using secure development practices if you aren't already. There are some really good guides out there, like OWASP and a few others. And then you can start looking into whether or not you need to protect your app using app shielding techniques on top of that. And that's the best practices for app shielding, essentially. I'm happy to do some questions. And afterwards, you can find us upstairs outside the Paris room.